In this lecture, we're going to see a way we can query for the size of an array at runtime. If you remember in the last lecture, we had an example like this, showing how we can declare an array and initialize it in a single statement like this. But the problem we had with this is that if we tried to print the array using a for loop, for example, we would have to use the size. And the size of this array may change if somebody decides to add elements or remove elements. Then the size is going to be irrelevant. C++ provides a way we can query for the size of an array at runtime, and we're going to get the real size accounting for the current number of elements that we have in the array. And for that, we use the stdsize function. This is a function that comes with the C++ standard library, so you're going to have it already if you have a compliant compiler. If you see here, you see that it was introduced in C++ 17, and it is a cool addition. We can use it to make our code easier to work with. If you look here, we have a simple loop which is going to print data out. It is going to loop starting from 0 all the way to the size of the array. You see that we use this to control when this loop is going to end. We then put in our incrementation part, and then we jump into the body of the loop and print the current element in the loop. And if we do things like this, we're going to be able to print all elements in the array regardless of the number we initialize it with. Okay, so this is one way, and it was introduced in C++ 17. But some of you must be asking, how did we do things before C++ 17? Well, we had to kind of do a hack to get something like this. We use the size of operator. We have seen a lot of times right now. And the way you use this, if you do size of and pass in the array, you're going to get the entire size of the array. So if we take that and divide that with the size of a single element in the array, we're going to get the number of elements of the array. And this is really what we are doing here. We are setting up a count variable, and we are taking the size of the array and dividing that with the size of a single element in the array. And we are just grabbing the first element because you can really use any element here. And once we have this, we can use this count to do a loop like this, and it is working pretty well. Please remember that you don't have to go through this craziness we're doing here. You don't even have to use stdsize, because you can use a ranged-based for loop and get access to the elements you have in the array, and it is going to work pretty well. Now that you have an idea about this, let's head to Visual Studio Code and actually play with this. Okay, so here we are in our working folder. We are going to be working on this project, size of an array. We're going to grab our template project. We're going to copy the files and put them in place. And we're going to open this up in Visual Studio Code. Let's do that. It's going to open up in Visual Studio Code, and we're going to try and clean it up a little bit. And we are going to declare an array. If we want to print this thing, we need to know how many times we're going to loop and print elements in here. So one thing you might want to do is to say, okay, we have 10 elements in here, so I'm going to loop for 10 times. You might think this is going to work, and it is going to work. If we bring up a terminal and build this with GCC like we usually do, and clear and run Rooster, we are going to get our numbers. This is what we have in the array from 1 to 10. But what if somebody comes and changes the elements we have in here? Let's add an 11 and a 12. And the moment we change this, we will need to come and change the size in here. And this loop here might be buried somewhere deep in your project, and it might not be as easy as it is now to see that we also need to change this. This may be a really big source of hard to debug problems. So what we really need is a way to get the size of the array at runtime and be able to dynamically query for that size and use it in our program. And that's exactly what stdsize provides. So we're going to say int count, and we're going to put in a value. Let's use a braced initializer. So we're going to say stdsize, and we're going to pass the array we want to get the size for. And if we do this, we're going to get this size here, and we're going to be looping for this number of times. So we're going to test for I is less than count here, And now it doesn't matter how many elements we have in here, we're going to get them at runtime. We need to only update this initializer here. So what we can do is build with GCC again. Now we're going to come here and run Rooster, and we're going to get the numbers here. You see that we get all the elements. If we take out a few of these elements, let's take out a few of these. Let's leave in up to 7 or 8. Let's build again, and we are going to clear and run Rooster. We're going to get however many elements we have in there, and this is pretty cool. Again, you might ask, how did we do things before C++ 17? Because std size was introduced in C++ 17. Let's say that here. Before that, we had to get the size of the entire array and divide that with the size of each element in the array. And we could use the size of operator to do that. So before we do any of that, we want to play with the size of method to really show you what it does. So what we're going to do is say std cout size of scores, the entire array, and we're going to print that. And we're going to say std cout size of, one element. Let's say scores, and use the first element. This is the easiest thing we can find here, but you can use any element. So we're going to say size of here, and we're going to say scores, and grab the first element, which is at index 0, and we're going to print its size. If we build and run this program, we're going to build and run, and the build is good. We can clear now and run Rooster. You're going to see that we're going to get size of scores is 32, the entire array. The size of one element is 4 because we are storing in integers. And I want you to see that 32 is 4 times 8 because we have in 8 elements. So it's going to give you the combined size of all the elements that we have in here if you do size of an array. But if you do size of a single element, you're going to get the size of a single element. So C++ developers were clever enough to see this and see that we could use this information and get the count of elements inside. So we can do something like int count, and we're going to assign a value to this in our braced initializer. So we're going to say size of, we're going to say scores, and we're going to divide that with size of, and we're going to grab scores. We can really use any element in the array, but we're going to grab the one at index 0. And now we're going to get the count stored in our count variable without using std size, and we can uncomment our array here or the code to print the array. And if we run now, it is going to work exactly the same thing regardless of the amount of elements you have in here. Let's put a few numbers randomly, and if we build and run, we are going to clear and run Rooster, and we're going to get all the elements in here. And you can really use any of these techniques. Just choose what you feel works better for you. Okay, we are going through all this trouble to set up an iterator. We're going to do the test. We're going to increment. This is really too much work to try and get data from a collection like an array. So what we can do instead is comment out all this hard work here, and we can use a ranged-based for loop as we have seen before, and it is ridiculously easy and convenient to work with. So what you can do is say for auto I, we're going to do type deduction on whatever it is we have stored in our array. So we're going to put a column and say scores, and we're going to print out the element. So let's do that. We're going to print std cout, and here we're going to say value. Let's say value in the array, and we're going to say I. And this is going to print all the elements, and we can work with the values inside if we want that. But you see that we have lost the information on the indexes. So if you really need the indexes, you will need to go through something like this. And if you just need the values in the array, ranged-based for loops are going to be really cool. Let's say range-based for loop. And if we build and run this, it's going to work pretty well. So the build is going to go through. Let's bring this up so that we have some breathing room. We're going to clear and a run rooster, and we're going to get our elements printed out here, and you see that it is the exact same thing we have in scores here. So this is really all we set out to do in this lecture. I just wanted you to be aware of the std size facility that we have in the C++ standard library. If you don't want to use it for any reason, you can also go in and do the division we did here to get the count of elements in the array. And do your best to try and use ranged-based for loops because they make it easier and cleaner to get data from a collection like we are doing here with an array. We are going to stop here in this lecture. In the next one, we're going to see how we can work with arrays of characters. Go ahead and finish up here and meet me there.